Welcome back. We're going to start our next panel from lab to table, applications of AI models across the agricultural value chain. Well, for those of you who weren't here this morning, I'm Henry Medeiros. I'm an associate professor of agricultural and biological engineering, and I work with AI and robotics applied to, well, agriculture. So our panelists here today are Dr. Felipe Ferrão. So Dr. Ferrão is research assistant science at the University of Florida Department of Horticultural Sciences at the Blueberry Breeding and Genomics Lab. He explores problems at the interface of statistics and genetics with a special focus on the use of multi-omic data for prediction and understanding of the genetic architectures of complex traits. Dr. Tilio is an assistant professor of horticultural sciences. He uses genetics, genomics, and system biology tools to explore the mechanisms on how transcriptional regulators integrate environmental cues and interact with signaling pathways to modulate plant growth. His research focuses on the study of post-harvest biology and technology, and I'm sure he's going to explain all that to you in a second. Dr. Haipeng Yu is an assistant professor at the UF Department of Animal Sciences. He's a quantitative geneticist with expertise in accommodating high-dimensional heterogeneous data to advance animal science. And today he'll be discussing the practical applications of AI in enhancing livestock farming systems. And finally, Dr. Ziwen Yu is an assistant professor of agricultural and biological engineering who specializes in big data analytics. He's interested in the data flow issues underlying the development of smart agricultural systems to automate future farms, mitigate the impacts from socioeconomic and environmental uncertainties. So our speakers will now have a few minutes to give a brief introduction on their current work on AI applications to agriculture, I suppose, and then we'll have a discussion. So, Dr. Ferrão, if you want to get started.
Hello, everyone. Can you hear me? So my name is Felipe. I think there is a good time to discuss about flavor, just right after the lunch. So this is part of a project that is called Deep Flavor, and the central idea is how we can use artificial intelligence to predict and understand flavor preference. So as you can see here, this is a large team. So we have like different professors from different departments that are working in this specific project. So I'm gonna start showing what is the main motivation behind of studying flavor. The central point that flavor is a very complex and subjective trait. So it's not only the chemical or the organoleptic aspects of the food that is going to affect the flavor, but also the cultural elements. So one example that I can bring here is thinking about the best dish that you have in your life that probably your mom or your grandmother is preparing. If I ask you exactly what is the recipe, and if I buy everything the same way, and if I prepare in the same way, you will never taste the same. And one of the reasons for that is because there are many cultural elements, and also our previous experience also has a kind of huge impact on our flavor preference. So when we are testing, for example, in the blueberry breeding program or in the coffee breeding program, if you want to understand if someone is enjoying the flavor, the most accurate way to do this is we're gonna providing consumers with a sample of this food, and then they're gonna quantify if the flavor is good or not. Okay, so but there are a couple of limitations when real consumers they are testing flavors. So number one is expensive, is time consuming, is low throughput, and also the data is too noisy. So I'm just gonna bring one example to say how this data is very complex. So this is a real data that we run in the sensory panel here at the University of Florida. We had 100 consumers. They tested 5 different fruits with different texture. And then we asked them to classify, hey, this fruit here is crisp, is firm, is soft, and take a look how messy is the data. So if you take a look at this point, we have a group of people saying that, okay, I'm eating this fruit, and this fruit is crunch. So then we ask them, give me a score between 0 and 100, and then for firmness, and he gave me like close to 0. And in most of the case, when we have consumers, when they are trying or when they are scoring berries, they created this kind of confusion because they cannot understand the scale. So this is a problem. So one of the ideas that we have is what happens if we include a camera in front of the consumers, and we start to record the face of the people. So then we can use artificial intelligence and also a huge data set that is in the web, basically, and based on the figures or based on the pictures, we can quantify what is the experience of the consumers. This is not new. So if you go to the Disney World right now, so you're going to see tons of cameras over there. It's not only to take pictures and sell the photos at the end of the experience, but also they want to understand what are the feelings of the guests when they are working or when they are going to the Disney World. So this is the kind of scores that we have when we are using deep learning or when we are using like facial recognition. We can understand what is the happiness, sadness, if the person has a surprise or an angry, and then we can compare this with the regular scores that the consumers they are scoring when they are eating the fruits. I just have a single result because we have only 5 minutes, right, Henry? So this is what we did with coffee. So this is a PCA, and what I want to put here is in black we have the regular ratings, the regular score. So the people they are drinking coffee, in red, and we ask them, hey, what is your score for aroma, or what is your score for overall liking? And then in black, we have the scores from the deep flavor or from the computer vision. And it's interesting to see that some negative feelings like the bitterness, when people are scoring bitterness, they can group together with negative feelings that we got it from the images, okay? Very simple example, just one result. We have this is a work in progress, so we want to try to connect now, include one more layer of data that is bringing chemical to the story and try to see what is the chemical of the fruit is going to affect our feelings, and this is the future direction. So thank you guys, and yes, I'm glad to take any question at the end. Right, Henry? Thank you.
Batilio?
Right. So just want to give an introduction of my lab, so working and overall what we studied. So we focus on the questions, which is the big questions of what the food waste and loss. And we know this is probably happen every day in a daily basis. You probably notice in your kitchens, there are a lot of food, vegetable and fruit that decayed. And if you're not cooked the right way, there's processing very fast. But overall, you can also notice those problems are very diverse. Some are, for instance, injuries or some of the infections, and all this could have leading to a different problem for vegetable and fruit. But overall, you can categorize this into 3 different major categories. For instance, for morphological changes or from physiological biochemical changes, and of course, there's a genetic difference also can play a role, and this you probably can see different. For example, different lettuce. If you purchase from grocery store, some lettuce maybe last for longer than the others. But overall, when you see the morphological changes, that means this already has all this physiological and biochemical has been developed. So in other words, this factors such as proteins and metabolites can be used as a marker to indicating the early decay process. So of course we want to understand the mechanism, but also we want to thinking, can we develop an easy tool to visualize those decay process? In other words, is there any indicator you can see in the early stage? So then, for instance, if you take a picture of your phone, then you're able to know how old those vegetables and fruits are, so then you can decide how long you can keep in the refrigerators. So to answer that question, so we're using machine learning tools. You can think about this as official recognitions for different decay factors. And this is, if we can characterizing those factors, then we're able to characterizing the early decay process. And same as the theory is we use imaging, hyperspectral imaging as a tool to characterizing this process. This is collaborated with Alina Zer's lab. And you can think in this, basically we use imaging to characterizing different compounds and at different times. So for a long story short, we can characterizing, for instance, this is a broccoli yellowing process, and use those imaging tools, we can correlate those compounds with the hyperspectral imagings. At the same time, also characterizing other problems, for instance, those avocado or passion fruit, how this decays. And this example, you can see the chili injury can be visualized in the avocado when they keep the refrigerator for a while. So the idea is whether we can use imaging tool to visualize those decay process and find a correlation between those indicators with the imaging process. And indeed, we also can visualize those changes. This is example from the hyperspectral imaging, as well as the you can see the shift of the graph and visualize those changes. In addition, we also can characterize different genotypes. In other words, different cultivars. What the difference you can see from these imaging tools. In addition to that, we're also looking at this imaging, for instance, use a CT X-ray imaging to characterize internal decay process, because that's what tells us what the internal and external difference among those. So using this tool, we can actually visualize, for instance, a passion fruit ripening process. So the overall, we want to just summarize them. Basically, we use different imaging tools to characterizing different post-harvest problem, and hopefully it can convince you each of different those process were characterizing a different model in an organism. And overall, for now, we want to design a generalized model to predict all this post-harvest problem in one time. So I think finally, just want to warn that food waste and loss is a really huge problem. It's really an issue that we should tackle these days. And hopefully, the AI and machine learning will be a great tool to helping us reduce food waste reductions. That's all for me. Thank you.
Good afternoon, everyone. So today I'm going to talk about the application of AI in the livestock farming system. And first, I will briefly introduce the background about this project. So for the precision livestock farming, it refers to an integrated approach that we utilize the sensor data and information technology to accommodate like the farming decision in the current livestock farming system. So computer vision as a subdomain of this like AI, it provides non-intrusive and cost-efficient way to collect this like real-time data. And then we can using this real-time data as like a great like opportunity to optimize the decision making. For example, the management, the breeding decision in the livestock farming system by providing individualized real-time animal care. And with the current available like computer vision tools and software in the public domain, there are many tools that we can use to like achieve this like purpose. However, the challenge is if you want to apply this kind of tools to the animal data, it involves steps such as like set up in the working environment, pre-process, post-process the data, and train, evaluate your model, and then visualize and implement in the practice livestock farming system. So this is always bring the challenge for the animal science community because it requires all the users to have certain data science programming skill set and also have access to their computational resources such as GPU and CPU. So additionally, with the growth of this precision livestock farming, there's like an increasing need to train and educate animal science students in this computer vision area. So with this kind of like a motivation here, I'm going to introduce the objective, which is we're trying to develop accessible computer vision tools. Specifically here is an open source, user-friendly cloud-based web application for users to perform object detection, segmentation, 3D visualization, and also feature extraction. And here, this is I want to talk about the details about this software, which is the open source user-friendly web application, Shiny Animal Seaway. And so we created the overall framework of this software using RShiny, and it includes two components, the user interface and the server side. So for the user interface, it offers the web pages, allow users to upload their data, specify what kind of task, what kind of models they want to use. And then this input will go to the server side. And the server side served as like a cloud-based computer. It will take the input from the user and then run it, get the result returned to the user interface. And then user can visualize and download this result. And here to achieve this like a computer vision task, we implement a modified mask RCN and also three additional Python computer vision and visualization packages. So in the current software, we implement two modules. The first module is object detection and segmentation. And as you can see here, this performed the segmenting, detecting all the two peaks based on the top view images. And in addition to this, we also implement a 3D visualization and feature extraction model. Here, we allow users to upload 3-dimension data collected from the camera and then perform this visualization and extract the information. So after we develop this software, our goal is to let everyone across the world just use it through the web pages. That's why we deployed this software in the Hypergator using an instance. Specifically here, we offered like a 32 CPU processor, 8 GPU, and 125 RAM. So with this, user can access to this software through across the world. And here, due to the time, I'm not going to show you demonstration, but if you are interested, you can access from this barcode to play around with this software. So in summary, here we develop an open source, user-friendly, web-based application for users to perform these various computer vision tasks. And even though currently we include 9 pre-trained computer vision model based on the pig and cattle data we captured, but we did realize this model maybe not works all well for the customer data. So that to overcome this, we released all the source code and also comprehensive tutorial on the GitHub, and the user can follow this tutorial to fine-tuning their model and then perform this inference locally by leveraging their own computing resources. So with this accessible computer vision tools, Shiny Animal Seaway, we anticipate it to facilitate the computer vision in teaching, research, and also extension in animal science community. Yeah, thank you.
Thank you, everyone. So today, my topic is how could data ethics be represented in digital agriculture? Instead of diving into AI and all these applications that 3 presenters have given their talk in here, I would like to bring the vision, kind of zoom out and see how AI or data technologies in general is changing the scope of the agriculture with these relationships between different stakeholders. So AI has changing the role of stakeholders in agriculture, And traditionally, farmers, especially, and the technology providers or these companies are in a relationship like customers and service providers. So farmers are not really engaged into the technology development. Traditionally, they just purchase the service and then they use the service. So all these development of technologies or services is actually solely independent by the companies. But with engagement or the implementation of AI right now, the technology advancement is actually relying on the data that contributed by the farmers or contributed by the data that collect from their farms. So in this case, farmers' role are not only a customer, they are also a contributor or engaged into the development of these technologies. So, and all these is a closed loop in right now or in a very, very strong loop in the future. So the connection is actually totally built on data. But the question for now on the ethic topic is who owns this data, and then how the value that generated from data can be shared into different stakeholders in a fair and justice way. So some efforts that we have done on review on these regulations from legislation perspectives is right now there's no good definition on ownership, especially for data. And in agriculture, there are some existing agreement made by industrial associations. So in the US or in EU, there's 2018, there's a code of conduct that regulate the ownership, share, and use of data in agriculture. And in the United States, there's a company called Ag Data Transparency, established in 2014, give these principles for companies to obey, that how to respect the contribution of, by farmers. However, these are non-binding agreements. Even though companies say we agree with these principles, we would like to participate into it. And if they violate all these principles, there's no legal enforcement is going to be put on them. So how law or legislation system can fit into this? And we dive into that, and we found that only one option, which is a trade secret, can be partially applied on data if contracts can be provided in the proper way to override all these copyright law specifications. And with different conditions, which is economic values and controlled disclosure. So as an example in here, so we trade secret has to represent these two features, economic value and controlled disclosure. So we pick, so if you have data come from farmers into a company, you need to represent these features, right? And then we pick an example from a kind of a giant company, provide data service to agricultural stakeholders. And then these are the specific terms that we extract from user's manual from their website. So I will highlight some piece in here. So if you agree that a company XYZ may use, display, perform, reproduce, modify, and distribute such data, which means farmers relinquish their rights to control the disclosure. And then without any compensation paid to you. So there's no economic value has been represented by this data transaction from farmers to companies. And which means it's not a trade secret owned by the farmer. So in this case, if farmers agree with these users' manuals, then they are literally giving the ownership to the companies, practically, and they cannot claim any rights based on their data. So how farmers understanding on this? So we did a social study in Florida, and we specifically asked questions about their understanding, their perception on data ownership. So you can see that I'm talking about the bar chart on the right. So there are two questions. Have they ever learned about data ownership? And are they familiar with these data obligations in the contracts that they have been committed to? So for undergraduate level education, so for farmers with undergraduate level or lower, most of them are not quite familiar with this, and they are not really understand the terms that they signed in the contract. But for graduate level farmers, half of them have been learn about these problems. And I have not shown the result in here. There's another question that we ask these farmers if they are not using these data services and why. So for the graduate level farmers, they said there only one person is not using this. And he said that the reason why we're not using this is data security. And for undergraduate level farmers, they are actually given the reason is we're not quite familiar, quite sure about the efficacy or efficiency that can be ensured by these technology. So those are something that we found that from social side, education is a very key factor to impact people's understanding on this. And consequently, if they are engaged into a contract or some data service, especially with AI, they are very likely to ignore these ownership and downstream consequences by agreeing these contracts. So, and now, so some works from our team. So we are trying to understand companies' perception on this. So we did some social study on companies who provide weather data monitoring in farms, and then we are working on the analysis on the results right now. Hopefully we can publish very soon. But what we found is companies generally agree that data is belong to farmers. However, they are not quite sure how these things can be put into their contracts, especially for small ones. For big companies, we are not able to even get in touch with them and to give a chance to interview them. So we're not quite sure what they're thinking. But based on the example that we extract from website, we can see that they have been getting to this situation and understand all these legislation tricks and putting to their contracts. And also, we are developing a NLP model, trying to understand the contract terms that we put an example in here and see how AI model can help farmers or even companies to understand these obligations and rights. Then knowledge base of industrial practices. So this is kind of a long-term objective. We're trying to gather more and more information into a language graph and network so that once you have a templates can be searched around these practices, that will be much easier for you to understand the whole thing. And then, so once you have all of this data collect and with a very steady and continuous process, how are we going to protect the security, the transparency, and other things regarding development of technology or potentially transactions. So blockchain is another topic that we are working on. And also the application of potential commodities generated from data, such as carbon market and other kind of ecosystem service functionalities. Okay, thank you.
All right, so now that we know what our panelists do, I have a few, very broad questions just to get the conversation started. So, I guess probably the first question that comes to mind is, how did you get into that, right? So, thinking about your experience with AI, what were the main barriers, right, that you found to adopting AI, and how did you overcome them, or did not, maybe? And key lessons that you learned. Do you think this is going to continue to exist? Do you think the landscape's going to change? Those are, past barriers. So. Maybe I thought Dr. Felipe can start. Hope you don't mind if I go by first names first.
Hey, hello everyone. So, at least from my perspective, we are in a horse science department, and I want to tell you that one of the main, I would say, barrier or limitation that we had in the past is like engage people or students in our department that AI, it's something feasible and something that people that they have this knowledge in agriculture, genetics, breeding, and plant size can dive in this area. So try to find like students, try to find like undergrads, people in my department that would like to dive in this direction, programming, statistics. It was one of I would say, it was a challenge. Let me put it this way. So in this specific project with Flavor, I'm working with undergrad from the computer science, but we have other master students and also PhD students in the blueberry breeding lab, and we are trying, like, step by step, trying to engage them and show that this is something feasible. We can bring, like, different expertise so they can learn the concepts. So we have good workshops and courses here at the university that they can build their background and also help on this kind of research.
Thank you. Do you want to weigh in, or maybe one of the other panelists has any additional thoughts in addition to the skill set of our
I
human
can just
resource?
echoing Philip's comments. I think for my opinion is their communications need to be encouraged between the horticulturists with the engineers. I think that's as we probably notice everyone today. There's this AI workshops are really fascinating. There's a lot of a very interesting tool that has been developed. But I have only see a very few horticulturists in the workshops, and I think that's really have a gap, which is how engineer understand agricultural problem and how the agriculturist can use the technology such as engineer tools to answer their questions and applying their either research. And I think there's a really huge gap is between the engineer horticulturists with our stakeholders, which is also our farmers and growers. They also need to know this, but there's knowledge barriers and gaps. So I think those workshops are really helping to bring collaborations and conversation with this. I think hopefully in the future, as more and more of this, we really can fill the gap for this areas. I think that's my 2 cents.
So it's not just a matter, I mean, it is a matter of skill set, but it's also kind of a matter of being able to communicate with the collaborators that bring in I know.
I just want to add a few points. Like I'm from the animal science, so we work with the animal. But my impression is for student, for researcher, for my colleague, and also the farmers, they are very willing to try this kind of like AI technology, AI tools. But I think the challenge for animal science community is actually we don't have this kind of like training or like in data science programming for us to have the ability to try this. I think that's the good part, like Philip and Tia bring up, we should have some collaborator from the people who are really can help us to implement this into this our research. But in addition to this, I think for me, what I learned is it's very hard if you only teach students, okay, what is AI, what it can help you, without telling them like what you can really use this kind of technology. I think the good part for us is we are thinking is we should bring the real farm question into the class. It's like we let the extension people, extension faculty or farmers came into the class and show them, or we can use in their like real time like monitoring video to show the student what is actually the real challenge in the farm. And then student can motivate it from these challenges to start using these AI tools. So I think for my group, as I just showed, but to connect this like real question to let students see, we need to create the tools, let students to be able to see, and then create some tools to let users to be able to try this AI tools to solve the question. So this is kind of like my group is trying to do. We want to create this kind of like a tools for students, for like our colleagues, and also for the farmers. So yeah, that's the part I want to add.
So I think the most important part, based on my research, is communication. And basically, if there's any AI development to be adopted by farmers, it has to be clear that what kind of group of farmers that you're targeting, especially for the communication, as I introduced in my presentation. If you are focusing on farmers with education level on a graduate level or even lower, then the communication should be focused on how effective and how efficiency that AI can improve in your farm. But if you are focusing on farmers with graduate level education, then it's more, so they basically know that AI technology is going to help them to manage their farm more efficient. But the question is how data security or these ethical issues you need to be addressed. So if there's any way can pinpointing the interest or the question for the specific farmers, then that will be more efficient for these adoption that can be proceed.
Thank you. And if the audience has any questions, about this, just raise your hand, and I'll be happy to bring this over to you. All right. Thank you.
Looks like Giannis has a question. You can ask him about p-values.
Hey, David, not again. So do you want me to ask the easy question or the hard ones? I have a lot.
Go for it. We're all friends here.
So Ziwen, we discussed that a lot in the past, but I think it's good to even bring it up here about data ownership. When we are talking about data, it's very complicated, right? I mean, what do we mean about raw data? Like, for example, images or videos, or the analyzed data, the visualized data, the analysis at the end, the reports, the decisions that you might help the growers to take. I mean, it's too complicated. And what is your thought on that? And also, I want to add also the example of even here, the cell phones, right? And we discuss it again. What we say, okay, maybe this device, the cost of this device is $10,000, but you can buy it only for $1,000. But they are going to use the data, our data, to improve the technology and to improve the applications that we use. So any thoughts on that?
So thank you for bringing the question. I'll answer the second question first. So basically, everybody is using smartphone. So when you're using smartphone, you need to agree on either Apple or Google's contracts or agreement in there. But I don't think anyone is really getting to the detail about the clause or the restrictions in there. And I think farmers are doing the same thing when they get into these services. So basically, a good way that we think for farmers to tackle in this, especially when the very complex data services, data ownership is a kind of very chaos landscape right now. So they have to be clear in asking how these things has been specified in contracts. And also, basically, if farmers own the data themselves, there's no value is going to generate from these data. Data has to be compiled together and put algorithm and do analysis on to dig in its value. So basically, sharing data is really necessary for future development in agriculture. But the question is how fair this could be. And like what I said, agricultural data has to be contributed by farmers. So how we can represent farmers' credits in these transactions by agree these clause or terms in the contract, and how are we going to put a fair terms in there. So something that we are thinking of, I also asked the question yesterday in the AI ethics topic today in the event as well. So so there are a couple ways that we can do. One is if farmers said, oh, if I contribute the data, and then can I get maybe 15% off from the service fee, or if I'm taking the ownership of data, I will also claim the profits that this data is going to generate in the future. So, for example, if companies are using the data to upgrade their service and charging more or resell back, then the farmers is going to get 5 cents from these new versions or new cells. But it's kind of for the requirements is to auditing these process. So data is very easy to be copy paste. So and how a third party or government is going to auditing these practices of further development or downstream consequences. Those are another technology challenge. So I cannot see any good solution at this point. So it's more like how the profit sharing should be represented and in a fair way. That is really unknown. And I don't see any good practices in the industry so far based on the contracts we can collect. And for the data ownership and the analysis, raw data, or other things, it's more, I would say that's a hard question. I don't want to take like half an hour in here to specify all the details in the legislation system. So basically, the important part I emphasize is in agriculture, data is quite different from social media. There's no personal privacy that represented in our data. So you cannot put these privacy protection laws or some hazard disaster restrictions on it. It's more like facts. So copyrights cannot be easily applied, or other laws cannot be easily applied to protect it. So how these things should be understood by farmers and companies as well, that's a very tricky part. And I don't think any education materials or resources are around that people can learn from these things. So knowledge gap is the first step that we need to work on, and some efforts need to be made, definitely.
So it's just to add to that, it's difficult to measure the value of data, right? But we all know it has value, right? We know a lot of companies today that, well, make a living by buying and selling data, but when you look at agricultural data, how do you quantify that? But on the other hand, to Johannes' point, when you are trying to start a company in that domain and you go talk to venture capitalists about your data collection devices, first question you get asked is, who owns the data? Right? So venture capitalists are well aware that that data is worth a lot, whatever a lot means, right? So, Charlie, please.
Yeah, I have one more question. I think several panel members mentioned about communication and the collaboration is very important to build a collaborative relationship between domain experts and maybe AI experts to advance this AI application in agriculture, because no one lab can possess all the skills necessary, right, to build an AI system. So my question is, what's your idea to, or your experience to build a successful collaboration in AI area, in agriculture? Yeah, what's your best ideas or experience? Thanks.
So that is an excellent question, and there is not an easy answer. So in my specific case, working with those two crops, that is coffee and blueberry, the first thing that I did was trying to figure out like groups inside of my department or in related departments that they are doing like similar research. So in the case of this research, the keyword was flavor. So I was trying to recognize, so what are the breeding programs that they are addressing flavor, and try to improve flavor using different methodology. And this was my I would say the starting point to tie this collaboration. So then I could find like the sweet corn group, the tomato group, strawberry. So all those groups are trying to also improve flavor or bring flavor to the front line of the breeding programs, and this was the starting point for collaboration. So again, try to identify professors, groups, PIs that they have similar objectives.
I can add on some experience from my collaboration with computer scientists, engineering, and also physiologists. So I think I agree with Philip. We need first identify what is actually the objective we want to get. Like we want to design what kind of like a system, what kind of like a component to help us. Then we can form our team. I think for me, when I collaborate with my collaborator, the thing I learned is even though you are collaborating from different areas, but you need to speak the common languages, which means as a PI, you still need to learn or like just learn the basic of what this different like a collaborator, what the area they can actually do. And then you can ask them, okay, what do we need for this project? This is my impression. We need at least have some common language we can communicate appropriately.
My strategy was to get a job at agricultural engineering department. So just to try and, we have just a few more minutes left, so I just wanted to maybe try and, shift the conversation a little bit to some other aspects of the AI applications in the agricultural value chain. So I think, Zhuan, you talked, you explained to us how complicated this whole data sharing problem is with the end user, right, with the grower. But what about us, right? I mean, researchers. Right? We know that one of the biggest things that contribute to this AI revolution, we can say, or the deep learning thing, is a lot of shared data, right? Large, open source, publicly available data sets. But in the agricultural life sciences, collecting data is a big part of the job, and sharing data is not as widespread. So, what do you think, in your opinion? Of course, I'd like you. The others to wait in if we have some time. What's your opinion? What's precluding us from doing that, and what can we do to fix it?
Well, I think it's very similar to the question that Dr. Lee mentioned. It's more like collaboration. And to me, I mean, I have some background from industry. So as from industry experience, it's more like how you can make a closed loop of business practice in there. So from suppliers to buyers. So if, for data collection, that's definitely the suppliers. And then when you collect these data, which expertise is needed to produce the product? And then who is going to buy this product? So if you can answer all these questions and to find the people from the beginning to the end to make all the business loop completed, then that would be much easier to make this collaboration and also data sharing. So basically, if the whole business idea is completed from, we collect the data and then we're going to save in here who is going to have access and do what kind of analysis and productizing everything into a way that can be open to the public or customers and how the transaction platform is going to be managed. And so step by step, what data is going to be passed over from one entity to another, that will be much easier to clarify. And then, so if that can be clarified, collaboration would be much easier to, specify the duties for everyone. Yeah.
Need to talk. Anyone else wants to weigh it in? We have about a minute left. Quick question, last quick question from the audience. Not, I guess we can wrap up this panel.
Let's be sure to thank our panelists. Thank you.
To our panelists.